Okay, so let's have a look at our first question here. We've got to solve this graphically. So if we go up the top here, to solve f of x less than g of x, we've got to determine the x values for which the graph of f of x is below the graph of g of x. Okay, so first thing we're going to do is solve f of x equal to g of x. So we're going to find where the two graphs intersect. So we're going to solve absolute value of 2x minus 5 equals to x plus 2. So first of all, we're going to look at the plus case. So 2x minus 5 is equal to x plus 2. That's going to give you x is equal to 7. Okay, and then we're also going to look at the minus case. So minus 2x minus 5 is equal to x plus 2. So you've got 2x minus 5. Just divide everything by -1 minus x minus 2. It's going to give you 3x is equal to 3. And then x is equal to 1. Okay, so you'll have to work out the corresponding y value for those points. So if you chuck in x equals 7 into one of these equations, so sub x equals 7 into, it doesn't matter which one, we will sub it into x plus 2. You're going to get y is equal to 9. Right, so therefore 7, 9 is the intersection. And for this one here, sub x equals 1 into y equals x plus 2, and then you're going to get y is equal to 3. Okay, so we've got two intersection points then at 1, 3 and 7, 9. So what you're going to do is you're going to draw the graph of the absolute value function and the linear function down here and mark those intersection points. Okay, so here you've got 7, 9, and here you've got 1 and 3. Okay, so your question is, when is the absolute value function graph below the linear function? Okay, so remember you've got to solve absolute value of 2x minus 5, and that's going to be less than x plus 2. So if you're looking for the sections of the graph which are below, okay, and you have to use the x values only. So the absolute value graph is the blue graph. So for which values is it below the pink line, if you like? Well, that's just going to be x is less than 7 and greater than 1. Okay, now you can't include the intersection points as part of the solution because it's just a less than symbol. Okay, now we can also use a graph to determine the number of solutions. So for example, this is actually difficult to solve algebraically to find the intersection points, but what we can do is we can graph both functions, the parabola and the hyperbola, and you can now I should actually change the words to that question there. It shouldn't be solved graphically, it should be determine the number of solutions graphically. So let me just cross that out for a minute. Okay, so the question should be determine the number of solutions for 9 minus x squared is equal to 1 over x. Okay, so we graph the parabola and the hyperbola on the same axes, and you can see here we can work out the number of solutions, which is just a number of intersection points. So there's one there, that's 2, and there's another one there. So you'd say just 3 solutions for that one. Okay.